Today's lesson is on quadrilaterals in the coordinate plane, and what we're really going to be doing is using coordinate geometry to make the most specific classification possible on the given quadrilateral. And what are we going to use for this? Well, we're going to need to remember the distance formula. So let's write that down. It's the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. We're going to use slope a lot, so I'll go ahead and write this over here. I know you haven't forgotten that though. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1, rise over run, and then we'll use the midpoint formula sum. That's a capital M, because remember slope is lowercase m, and that's x sub 2 plus x sub 1 over 2, y sub 2 plus y sub 1 over 2. And so here we go. So what I think you should do here, guys, is this could be a long lesson. So before we even get going, I'm going to pause here and I'm going to label all my vertices in these pictures so that it's easier for me to do the slope and maybe find the distance if I need to. And then on the problems like these, which all the rest of them mostly are, I'm going to go ahead to the left and draw my sketches. So you should do that too. Pause here, and then when we come back, we'll just have to do the algebra to find the slopes and the distances, and then we can classify our quadrilaterals. So pause here and get all that set up, and then we'll come back and roll on through this. Okay, let's roll here. Is GHIJ a parallelogram? Well, what I'm going to do is I'm going to find the slopes of all four sides, and that'll tell me whether it's a parallelogram or not. So let's start with the slope of GH, and that's going to be 4 minus 3 over 0 minus negative 3. So that's 1/3. And now I'm going to find the slope of the side opposite GH, which is JI, I think. The slope of JI is -1 plus 2 divided by 4 minus 1. So I get 1/3 again. So looking good so far. So let me find the other two opposite sides slopes. The slope of GJ is -2 minus 3, so -5, over 1 minus -3, 4, and the slope of HI is -1 minus 4, so -5, over 4 minus 0, 4. So yes, it's definitely a parallelogram, and how do I know that? Because of the definition of parallelogram that says if a quadrilateral has both sets of opposite sides parallel, it's a parallelogram. All right, so now we've got, I think, 4 problems just like this one. So what I'm going to do is I'm going to do the entirety of this first one with you, and then you can pause and do the next 1, 2, 3. Yeah, there are 3. So we're going to do this one, and then you'll do the next 3 on your own and check your answers. So what is the most specific classification for ABCD here? Well, first let's check to see if it's a parallelogram, just like we did above. We're going to find the slope of AB, and that's going to be -2 plus 4, so 2. 8 minus 9 is -1, so that'll be -2. Let's find the slope of the opposite side. The slope of CD is -7 minus -5, so -2 over 3 minus 2. So that pair of opposite sides has the same slope. So let's find the slopes of the other two opposite sides. That would be BC. Slope of BC is -5 plus 2, so that's -3. And 2 minus 8 is -6, so that's a half. The slope of AD, and the slope of AD is going to be negative 7 plus 4. So negative 3 over 3 minus 9, negative 6. So I got a half. So, definitely a parallelogram. And look what else we have. Look at these two slopes compared to these two. What are they? They're opposite reciprocals or negative reciprocals. So we know we got a rectangle here for sure. We've got a parallelogram because we just showed that both pairs of opposite sides are congruent, but we also showed that consecutive sides are perpendicular. So we know it's a rectangle, but now we got to check to see if it's a square. We can't rely on our drawing to say, oh, of course it's not a square. I can see that. So we've got to do the algebra. So let's see, what can we do here? We got two choices, right? We could look at the diagonals. We could check to see if they're perpendicular. If they're perpendicular, it's going to be a square. Or we could find the lengths of consecutive sides. So I don't know. Let's just do that. Let's find the length of BC. And let's see, BC. That's going to be 8 minus 2 squared plus negative 2 plus 5 squared. So that's going to be 36. And 3 squared is 9, so that's going to be the square root of 45. I'm not going to simplify that because that's not my final answer. I just want to see if BC and AB are the same length. And then I know I've got a square. Pretty sure they're not, but we got to go ahead and prove that. So let's see, AB is 9 minus 8 squared plus negative 4 plus 2. Negative 4 plus 2 squared. So that's 1 squared plus negative 2 squared. So that gives me the square root of 5. So definitely not a square because all sides would have to be congruent. And I've just shown that that's not the case in these two steps. So rectangle. That is our most specific classification. Okay, so as I told you, there are 3 more of these, and I want you to do them. I want you to draw your sketches. First thing I would do is I would check to see whether or not these quadrilaterals are parallelograms. Look at number 2 here. Kind of looks like a kite based on my drawing, but who knows? What are you going to do? You're going to find the slopes of all the sides to see if opposite sides are parallel, and then go from there. So you're going to pause and do 1, 2, the next 3 problems, and then I'll have the answers up here when you get finished. All right, here we go. On this problem, after I found the slope of QR and the slope of ST, those are opposite sides and they got the same slope. The other pair of opposite sides have the same slope, so I know it's a parallelogram. Now I need to find if it's anything more specific than a parallelogram. I know it's not a square or a rectangle because the consecutive sides are not perpendicular. If they were, these slopes would be negative reciprocals, right? So it's not a square, it's not a rectangle. It might be a rhombus though. How can I decide whether this is a rhombus or not? Well, I got 2 choices. I can find the lengths of 2 consecutive sides, or I can find the slopes of the diagonals. If they're perpendicular, I know it's a rhombus, and that's what I decided to do here. I sketched in my diagonals, as you see there in red. I found their slopes. One slope is undefined, one slope is 0. Therefore, I know the diagonals are vertical and horizontal, and they're perpendicular. That means QRST is a rhombus. Number 3, using the slope, I found that it is a parallelogram. Then I had to decide, is it a rhombus? Because like the previous one, I know it's not a rectangle or a square, because these slopes are not negative reciprocals. Well, yeah, it looks like it's not a rhombus, but I have to prove that using algebra, so I used the distance formula this time to check the side lengths. I check the length of side ML. I got the square root of 18, which again, I'm not going to simplify because that's not the final answer. I'm just trying to find out if it's equivalent to KL. And when I did the distance formula there, I got the square root of 73. Those are not equal. They're not congruent. So this is not a rhombus. It's most specifically a parallelogram. Okay. On the fourth one here, just like always, found the slopes of the opposite sides, and yes, both pairs of opposite sides are parallel, so it's a parallelogram. But look, I can see that because consecutive sides are perpendicular, it's also a rectangle. Now I got to check to see if it's a square. So I did the same thing here that I did a while ago. I sketched in the diagonals in red. I found their slopes. The slope of WY is negative 2/3. The slope of XZ is 3/2, which is its negative reciprocal. So I know the diagonals are perpendicular, and that means I have a square most specifically. Okay. And then, looking at this next problem, I went ahead and wrote some notes on this. So the first thing I got to do here is I got to find the midpoints of all the sides of this kite, because it says what is the most precise classification of the quadrilateral formed by connecting the midpoints. So I found those midpoints here, 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 and I sketched those in, as you can see in my drawing here. Okay, well, it just so happens that the sides of this quadrilateral, one pair of opposite sides is vertical, one pair of opposite sides is horizontal, so I know that those consecutive sides are perpendicular. That means I got a rectangle. But do I have a square? Well, I can easily see, because this thing is on graph paper, that these sides, these horizontal sides, are 6 units, and the vertical sides are 4 units long, so it's not a square. It is most precisely a rectangle. All right, let's see what we got here. The last few problems, they're really the same, but they look a little scarier, I guess, because they don't have coordinates that are numbers. We just are going to use letters, and that's okay. We can do that. Let's see how we do it. What are the coordinates of the vertices of each figure? SQRE is a square. SQ, so the length of each side is 2a. Since it's a square, I know the length of each side is 2a. So half of that would be a, right? If I divide 2a by 2. So each little piece here is a, making each side 2a units long. And we just want to find the vertices. Okay, so let's start with R. If I come over a units and go down a units, that means the vertex R is going to be a, negative a, right? Excuse me. For Q, I come to the right a units and I go up a units. So that vertex will be a. S is going to be negative a, positive a, and E would be negative a, negative a, because I go left a and I go down a units. That's all there is to it. Okay, why don't you pause and try to do the rectangle here and see what you get for its vertices. Okay, is this what you got? For T, I'm going over B units. I'm not going up or down, so that vertex would be B0. For vertex C, I'm going to the right B and I'm going up A. So I'd have BA for vertex C. For vertex E, I got to go to the left B and I got to go up A. So negative BA would be that vertex. And finally, vertex R, I got to go to the left B. I don't go up and down at all. So negative B0 would be that vertex. Okay, finally, the diagram below shows a trapezoid with the base centered at the origin. Is the trapezoid isosceles? Explain. This is a great problem, and I am not going to solve this. I want you to do this. It looks isosceles, doesn't it? But think about what you know about an isosceles trapezoid. There's more than one way you can do this. I want you to pick one of those ways and find out, is this isosceles? What do we know? I'll give you a hint here. One thing we could do is if we could find that the diagonals are congruent, then we'd know it's isosceles. We could also find out if RT is congruent to AP, right? So you can choose either one of these methods to decide whether this trapezoid is isosceles, and I will check to see how you did on that next time.